Good evening, sir.
Good evening, madam.
Sir, you can start, sir.
Okay, madam. Thank you.
Good evening, sir.
Good evening, Appa.
Good evening, sir.
Yeah, good evening. Okay. Just 1 second. Delete ಆಗೋಗಿದೆ. Yeah. Yes, can you see the screen sharing?
Yes, sir.
Yes, sir.
Okay. So we have to do this problem, right?
Yes, sir.
Yeah. Yeah. Look at the problem. What they have given. A glass prism is given. What is the refractive index? 1.5. That is immersed where? Water. What is the refractive index of water they have given? 4/3. Now, the light beam is incident normally on the face AB, is totally reflected to reach the BC. Now it is going to reflect at this point to reach the BC. To reach the BC. Can you tell me the relation for sine theta? Can you tell me the relation for sine theta? When the total internal reflection will takes place, Appa?
Sir, when it is greater than the critical angle, sir.
Very good. So here, what is the angle of incidence? Theta, right? So that sine theta, can I conclude, should be more than the sine of the critical angle? Because total internal reflection will takes place if the angle of incidence is more than critical angle.
Critical angle, sir.
So this is the condition for what? TI.
So total internal reflection.
So for the total internal reflection, the angle of incidence must be greater than the critical angle. Here angle of incidence is theta. Here the angle of incidence is theta they have given. So if theta should be more than C, if theta is more than C, can also conclude sine theta is more than sine C. What is sine critical angle? What is the formula for the sine C? It is the ratio of refractive index, right?
Yes, sir.
It is the ratio of the refractive index.
Yes, sir.
Now, Numerator should be a rarer medium, that is refractive index of water. Denominator should be more than water medium, that is glass. Sin C ratio should be always less than 1, right?
Yes, sir.
So in order to get the ratio of sin C less than 1, numerator should be water, denominator should be a glass medium refractive index. So sin theta should be more than, sin C should be equal to mu W divided by mu G. Mu W divided by what? Mu G. So what is mu W? What is refractive index of water?
Sir, is it 1.33, sir?
Or you can keep it in ratio only, my dear. You can keep it as 4/3 instead of 1/3.
Yes, sir.
1.33.
Yes, sir.
What is refractive index of glass?
So 1.5, sir.
1.5 can be taken as 3
3
by
by
2.
2, sir.
No.
Yes, sir.
So 2 goes up, right?
Yes, sir.
If 2 goes up, it becomes what?
So sine of 8 by 9.
Sin theta should be more than what?
8 by 9, sir.
8 by 9. 8 by 9. Clear? Actually, whenever the ray of light is incident here, this is called the normal. This is called the angle of incidence, which should be theta only. In undergo the reflection, in undergo the total internal reflection, this theta should be more than what? Critical angle. That is the condition what I am going to use here. That is the condition which I am using here. So which is the right option?
Option A, sir.
Option A. Yeah. Look at this problem. When light is incident on a medium at what angle? I. Refracted in the second medium at an angle R. Sin I versus sin R. So here it is sin I. This is sin R. Sin I is taken along y axis. Sin R is taken along. They have not mentioned in the figure, right?
Yes, sir.
They have not mentioned anything in this case. How to solve then? How to solve this? Which one we have to take I and which one we have to take R? There is some error in this question apart. We don't know which is an this thing. Let us assume we will take sin R on the y-axis, sin I on the x-axis, because usually we are varying I. How R is changing with respect to I, we are measuring. So let me sin R will be in along y-axis, sin I will be in x-axis. Yeah. Now you have to conclude which is the right option here. Now this is a straight line, right?
Yes, sir.
For the straight line, can I try to find the velocity of light and the critical angle? Because one option is talking about critical angle. The other options are talking about the velocity of light. Velocity of light. Can you tell me what is tan 30 from the diagram? From the graph? What is tan 30? Opposite by adjacent, right?
Yes, sir.
So what is opposite here? Sin R?
So sin R, sir, by sin I.
Sin R by sin I. Sin R by sin I. So from Len's law, sin R by sin I is nothing but mu1 by mu2, right? Because sin I by sin
sir.
R is mu2 by mu1.
Yes,
What
sir.
is sin R by sin I?
So mu1 by mu2.
Mu1 by mu2. Mu1 by mu2 can be taken as V2 by V1 because refractive index is inversely proportional to velocity, no?
Yes, sir.
Yeah. What is tan 30?
So 1 by root.
So V2 by V1. On cross multiplication, velocity of the first medium will be how much? Root 3 times of V2, or I can take root 3 as 1.73 into V2. So velocity of the first medium is equal to what?
So
1.73 times the velocity of the
into velocity of the second medium.
velocity of the second medium. Velocity of the second medium. So among this A and B, option B is correct. But please cross check about the critical angle also. Please be very careful. You have to cross check the critical angle conditions also. Now you know what is critical angle, right? What is critical angle? It is the ratio of two refractive index, right?
Yes, sir.
Yeah. Two refractive index. Or you can take velocity ratio, right? Can you tell me V1 is more than V2? No.
Yes, sir.
Or in terms of refractive index, N1 is less than N2. Because refractive index and velocity are inversely proportional. So sin C should be equal to N1 by N2, no? Numerator should be less refractive index, denominator should be more refractive index. So N1 by N2 can also be taken as V2 by V1.
Yes, sir.
So sin C is equal to, what is V2 by V1?
So 1 by root 3.
1 by root 3. So sin of the critical angle is also equal to 1 by root 3. So related to critical angle, sin IC represents critical angle here. So sin C is equal to 1 by root 3. So even option C is also correct. So for this special case, the two options are correct. That is both B and C. Both B and C. So sin critical angle is also equal to 1 by root 3. So even option C is also correct. So both B and C are correct. You got it?
Yes, sir.
Yeah. Yes. Look at this. Look at this. A beam of light is consisting of how many colors? Red, green,
And blue.
and blue colors. That is incident on the right angled prism. Refractive index of the red, green, blue. What is the refractive index of red? 1.39. What is the refractive index of green? 1.44. What is the refractive index of the blue? 1.47. Now they're asking you to find the prism will separate which colors? The prism will separate which colors? Suppose if any ray is undergoing a total internal reflection, that angle of incidence must be more than what? More than what?
So it must be more than
Critical.
the critical angle, sir.
Yeah. Now, can I tell sine I is equal to sine C? If I is more than C, can I conclude sine I is more than sine C?
Yes, sir.
Sine I. What is I here? This is 45 degree. So if any ray of light is incident, at what angle it should be incident? 45 degree, no?
So
So sine 45
sine 45, sir.
should be more than what? Sine C.
Yes, sir.
What is sine 45?
So 1 by root 2.
1 by root 3 is more than. Sine C is nothing but 1 divided by refractive index, no? Sine C is 1 by n, no? That is the refractive index of that glass prism. So if I cross multiply, Ng should be more than what? Root 2. So what is the refractive index of glass? Root 2. Root 2 can be taken as what? What is the root value? 1.41, no?
Yes, sir.
So refractive index of glass is 1.414. Look at this. Refractive index of red is less than the refractive index of glass. But look at refractive index of green and refractive index of blue. These both are more than the refractive index of what? Glass, no?
Yes, sir.
Green refractive index and blue refractive index. 1.44, 1.47 is more than this. So these two colors are more than the refractive index of glass. So this ray will undergo what? Reflected. All this ray will get reflected, green and blue. So red color is get separated. Why red color will get separated? Because the refractive index of that red is less than the refractive index of glass. So green color and blue colors are going to get separated. So can you tell me which is the right option? Option A, no?
Option A, sir.
Separate part of red color from green and blue. From green and blue. Green and blue will undergo reflection. Since refractive index is more, it should be reflected. So green and blue color is get separated from red, or red color is going to form a separate one compared to green and blue. So if any refractive index is less than √2, that ray will undergo TIR. So these two rays will get reflected. Yeah, look at this. There is an air bubble, right? There is an air bubble.
Yes, sir. Yes, sir.
In a glass slab of what refractive index?
So mu equal to 1.5.
1.5. 6 centimeter deep when it is viewed from one face. You can get the image of the air bubble at what distance?
So 6 centimeter.
When you viewed from one face. And when you viewed from 4 centimeter deep, when you viewed from the opposite face. They are expecting you to find what? They are expecting you to find what? Thickness, right? Correct, no? Now, I will consider one glass slab. I'll consider one glass slab. The refractive index of this glass slab is given. N. How much it is? 1.5.
So 1.5, sir.
Actually, in this glass slab, there is one bubble. There is a bubble here. Let us say this is the first phase. And this is the second phase. Now, the actual distance of the air bubble, we don't know where exactly it is. Let us say it is at a distance x from the first phase. We don't know what is the thickness of the slab also. Let T is the thickness of the slab. Can you tell me what is the separation of the bubble from the second phase? The total thickness of the slab is T. The air bubble is at a distance of x from the first phase. Then what is the distance of the air bubble from the second phase? What are you doing? What is the thickness of the slab,
Sir.
Appa?
Sorry, sir. Sir.
T.
Yes, sir. Sir, it is T. Sir, that small portion will be T minus X, sir.
T minus X. Now, what is the condition that given? What is the condition they have given? It is going to be seen at 6 centimeter deep when it is viewed from one face. If I view from first face, that bubble appears to be here. The image of that image. At what deep? 6 centimeter.
Yes.
When I do the same thing from the opposite face, it appears to be at what depth?
So 4 centimeters.
4 centimeter. Yeah. Now, can you tell me the refractive index for the first phase? For first phase,
Sir,
how do you define
1.5,
refractive
sir.
index? No,
So
no,
1.
real depth by.
Yes, sir. Real depth by apparent depth, sir.
Refractive index is given by the real depth by the apparent
Apparent
depth.
depth, sir.
So refractive index is equal to real depth is x,
Yes, sir.
apparent depth is 6.
6 centimeters.
For
sir.
first phase, this is real depth, this is apparent depth, x by 6. For the second phase, refractive index must be same, no? Because same slab. So what is real depth by apparent depth for the second phase? What is the real depth for the second phase?
So it will be T minus X divided
What
by
is the
4
apparent depth?
centimeters. Sir. 4 centimeters. Sir.
4. What is n value they have given? What is 6 into 1.5? 9 centimeter. N is 1.5. T minus 9 by 4 because x is 9 centimeter. Cross multiply. 6 is equal to T minus 9. So T will be 6 plus 9. What is 6 plus 9?
So 6 plus
15
9 is 15,
centimeter.
sir.
So what is the actual thickness of the?
Option C, sir. 15 centimeter.
Yeah, 15 centimeter. Got it?
Yes, sir.
Actually, this is important one. They have asked in many a times in competitive. Any doubt in this problem, Appa?
No, sir.
Yeah. Let us take up the last problem on plane surface. It is almost similar to the previous one. Let me read the problem first. What is given?
So rectangular glass plate, sir. 6
What is the
centimeter.
thickness of that glass
6
plate?
centimeter.
And one face is?
Silver, sir.
Yeah. Object is held?
So 8 centimeter.
8 centimeter, right?
Yes, sir.
In front of the first face. That forms the image where?
12 centimeters, sir.
12 centimeter behind the
So silver face.
silver face. They are expecting you to find what?
So refractive index, sir.
Yeah, refractive index. So here you have to be properly understand the diagram part. You have to understand the diagram part properly here. Let me write one rectangular glass plate. This is rectangular glass plate. What is the thickness of that plate they have given?
So 6 centimeter.
Thickness of the plate is 6 centimeter. Shall I mark this as 6 centimeter?
Yes, sir.
Then what is the second condition? It is silver. This is silver. Okay.
Yes, sir.
Now, the object is placed This is object. This object is placed at what distance?
So 8 centimeter.
8 centimeter from the surface, isn't it? For
sir.
this object, where the image is going to be formed, where the image is going to be formed, they have
Sir,
given
it is
no.
formed 12 centimeter behind the silver face, sir. The other side, sir.
Yeah. Shall I write that as somewhere here?
Yes, sir.
Image that is formed at this distance. What is that given?
12 centimeters, sir.
Yeah. 12 centimeter. Now, my question is, whenever this mirror is placed here, when you polish this, the bottom surface it is polished, there will be a shift in this silver face. Correct? No? Normal shift will be there, no bottom surface.
Yes, sir.
So, there will be a shift in the silver face. What is that shift called? Normal shift. What is the apparent depth? X. X is the apparent depth. Correct? No. So it looks that the plane mirror gets shifted. So the silver face gets shifted. That silver rays will get shift because of the normal shift. So actually for this object, silver face will appear where? At this point. XY will be the mirror for what? For object. Are you getting my point?
Yes, sir. Yes, sir.
When you polish the bottom surface, that polished surface will get shifted, no, because of normal
Yes,
shift.
sir. Yes, sir.
So that shifted will be XY. So
Yes, sir.
XY will act like a plane mirror for what?
Sir, for the object.
Yeah, because when the object sees the mirror, for the object, the mirror will not be at the same position. That mirror should get shifted because of the normal shift, no?
Yes, sir.
So that is the logic behind this. That is the logic behind this. So
Yes,
I
sir.
can tell XY acts as,
So the plane mirror, sir.
yeah, plane mirror. Yeah, you can add that also. XY acts as a plane mirror
For the object, sir.
for the object O. For the object O. You know that in the case of a plane mirror, object distance is equal to image distance. Object distance is equal to what?
Sir, image distance, sir.
For plane mirror,
Yes, sir.
you can tell object distance is equal to what?
Sir, object distance is equal to the image distance for plane mirror.
Object distance is equal to the image distance. For the plane mirror, what is the object distance? 8 plus x, no?
Yes, sir.
Look at the diagram. 8 plus x. equals to. What is the image distance?
Sir, NS plus 12.
Don't tell in terms of NS, appa.
Yes, sir. Sir.
NS can be taken as 6 minus x.
Yes, sir. 6 minus x plus 12, sir. Then.
Yeah. 6 minus x plus 12. So on simplification, 8 plus x is equal to, shall I write 18 minus x? Correct, no? So what is 2x? 10. So what will be x? 5 centimeter. So x is 5 centimeter, isn't it?
Yes, sir.
Yeah. But they're expecting you to find what? They're expecting you to find what? What they're asking you to find?
Sir, the refractive index, sir.
Now I know the real depth. I know the real depth.
Yes, sir.
And I know the apparent depth.
Yes,
What
sir.
is the refractive index formula?
Sir, real depth by apparent depth.
Real depth by apparent depth. What is the real depth here?
Sir, 6 centimeter
What
divided
is
by
the
5.
apparent depth? 5.
Sir, apparent.
Apparent depth is 5.
Yes, sir.
So what is 6 by 5?
So 1.2, sir.
So which is the right option?
So option C.
Option C. Are you feeling difficult?
So this is slightly tough, sir, but yes, sir, understood, sir.
Yeah, because MCQ NEET exams competitive means you have to think like this, because there will be two types of refractions actually in this problem. Bottom surface is silver and that bottom surface will get shifted because of normal shift. That is the hint in this problem actually. The students will not think about the normal shift here because they have not told any hint in the problem. So these are the different varieties of problems in the case of plane surface. Shall we move on to the next refraction, that is refraction through prism?
So could you repeat, sir?
These are the varieties of problems in plane surface, Appa. Shall we
Yes,
pass
sir.
on to the next type of refraction, that is refraction
Yes,
through
sir.
prism?
Yes, sir. So for curved surface, sir, plane mirror curved surface.
That will take up the next concept, that is spherical surface.
Yes, sir.
We'll take that in the spherical surface.
Okay, sir.
Yeah. Now, let me analyze the refraction. The refraction through what? A prism.
Yes, sir.
You know what is prism?
Yes, sir. Sir, it's an optical surface bounded by 2 triangular faces and 3 rectangular faces, sir.
There will be 2 triangle and 3
Rectangular.
rectangular will be there. So prism is an optical medium bounded by 2 triangle and 3 rectangular faces. It looks like this. This is one rectangle, right?
Yes, sir.
This is the second rectangle. This is the third rectangle. In this is the 2 triangles. So 2 triangle, 3 rectangle. That is what we called as a prism. I'm going to consider the perpendicular section of this prism. It looks like this. The perpendicular section of the prism looks like this. This is completely polished, where the refraction will not take place here. This is called the base of the prism. What is this called? Base of the prism.
Base of the prism, sir.
The refraction can take place. The refraction takes place from AB and AC. These 2 surfaces are called the refracting surfaces. Whatever the angle is made between the 2 refracting surfaces, this angle we call it as the angle of the prism. What is A? Angle of
Sir, angle of the
prism.
prism.
Yeah. Now, I'm going to incident a ray of light at an angle of incidence I1. I'm going to incident a ray of light at what angle? I1. The ray will undergo the refraction, and that angle of refraction is R1. Can you tell me what is I1 and R1? I1 is
Sir,
the angle
I1
of
is angle of
incidence for the
incidence.
first phase AB.
Yes, sir.
R1 is the angle of refraction for the
first
second phase.
Yes, sir.
At the second phase, shall I write one more normal?
Yes, sir.
This will be the angle of incidence. I will denote with R2. Here it will undergo the refraction. This is the emergent ray. Angle of refraction, I will take it as I2. R2 is the angle of incidence for the second phase. I2 is the angle of emergence or angle of refraction for the second phase. Suppose if I am not keeping the prism only, then how the ray PQ would travel? In the absence of the prism, how the ray PQ would travel? Actually, in the prism,
Sir,
the
it
ray
goes
is
straight,
coming
sir.
from P
Sir,
to
it will go
Q,
straight.
Q to R, R to S. Suppose
Yes,
if
sir.
the prism is not
Sir, it
there,
will go straight, sir.
it will go straight. Very good. It will go straight. Because of the prism, instead of going straight, it is get deviated like this. That angle we call it as an angle of deviation D. What is small d represents? What is small
Sir,
d
angle of
represents?
deviation. Angle of deviation.
Okay. So what is that D represents? Angle of
Sir,
deviation.
deviation, sir. Angle of deviation.
Yeah. So please remember these formulas. You can prove angle of the prism is equal to R1 plus R2. Deviation is given by the formula I1 plus I2 minus A. What is the angle of the prism formula A? R1 plus
Sir,
R2.
R1 plus R2,
Deviation is given by the formula I1 plus
I1
I2
plus I2 minus A.
A. If I1 is equal to I2, this implies R1 is also equal to R2. In this case, A will be equal to R by 2, and I will become A plus capital D by 2, because here we are going to take small d as capital D. We are taking small d as capital D only if I1 is equal to I2 and R1 is equal to R2. That capital D, we call it as minimum deviation. We call it as what?
So minimum deviation.
Minimum deviation. So if I use this Lenz's law here, n is equal to sine of A plus D by 2 whole thing divided by sine of A by 2. This is called a prism formula. What is this called?
So prism formula.
So please remember all these formulas related to the prism. So when I'm using capital D, it is understood we are talking about minimum deviation. Under that minimum deviation, I1 must be equal to I2 and R1 must be equal to R2.
R2, sir.
That is the condition. If angle of the prism is less than 10 degree, then such a prism we call it as a thin prism. What is thin prism? Thin prism is the one.
So thin prism, sir.
Thin prism is the one whose refracting angle is less than 10 degree. Please remember the deviation for thin prism. Deviation for thin prism is given by the formula n minus 1 into A. What is the deviation formula? N minus 1 into A. You can consider this deviation formula only for which prism? Thin prism. So what is the deviation formula for the thin prism?
Sir,
N-
D is equal to n minus 1 into A.
N minus 1 into A. Got it?
Yes, sir.
Yeah. Look at this. You have to tell me now. This is prism. This is BC. This is A, angle of the prism. I'm going to write one more diagram, Appa. Angle of the prism, BC. Yeah. What is A called?
Sir, angle of prism.
Yeah, A is called angle of the prism, right?
Yes, sir.
Yeah. Now, look at here. First case, I will take the normal ray. It is incident normally. This is the normal. Now, the ray will graze us like this. Second case, I'm taking this is one normal. I'm incidenting the ray along this. Then it undergoes refraction. Here one more refraction. This is moving like this. Have you got the difference between these two?
Yes, sir.
What is I1 here?
Sir,
Zero.
yeah,
Normal
I1 is zero.
incidence.
Yes, sir.
No angle of refraction. R1. What is I2?
So 90.
I2 is 90. If the angle of refraction is 90 degree, what is this corresponding angle called?
Critical angle, sir.
Very good. So that R2 will be equal to C?
Yes, sir.
Yeah. Can you tell me what is angle of the prism here? A equals
Sir,
to R1 plus
R1 plus
R2.
R2, sir.
So
Sir,
A
C,
is
sir. It's
equal to
C.
0 plus C. So what is A? C.
C, sir.
So angle of the prism is equal to what?
So critical angle.
Critical angle when you incident at 0 degree. Come to the second diagram, Appa. Come to the second diagram. Can you tell me what is I1?
So 90.
If I1 is 90, what is this corresponding angle called?
So
Critical angle.
critical angle, sir.
Now it is undergoes refraction and it grazes here. So if it grazes here, what is this I2?
90, sir.
What is this corresponding angle?
Critical angle.
So this is R2 actually. We can make this as R1. So can you tell me what is the angle of the prism here?
Sir. Sir, it is equal to 2C, sir. 2C, sir.
Yeah, A is equal to 2C. A is equal to 2C. So what is the conclusion from this? Whatever the angle of the prism is there, that should be more than or equal to critical angle, and it should be less than or equal to twice the critical angle. So A value can't be less than C. Angle of the prism can't go beyond critical angle. Similarly, angle of the prism can't be more than what?
Critical angle, sir.
Twice, 2 times of the critical angle.
Yes, sir.
Because angle of incidence is going to vary from 0 degree to what? 90 degree. So what is the minimum angle of incidence? 0
Sir,
degree. What is the maximum angle of incidence?
90, sir.
So for minimum angle of incidence, angle of the prism is C.
Yes, sir.
For maximum angle of incidence 90 degree, what is the angle of the prism? 2C.
Yes, sir.
So this clearly tells angle of the prism should lie between the critical angle and the twice the critical angle.
Yes, sir.
Yeah. For example, if I give the critical angle of the glass prism is 30 degree, can I expect the angle of the prism to 20 degree? Can I expect the angle of the prism as 20 degree?
Sir, no, sir.
Not possible, because for the minimum angle of incidence, A must
Yes,
be
sir.
equal to C.
C, sir.
So angle of the prism should not exist with 20 degree.
Yes, sir.
Similarly, can I expect 70 degree?
Sir, yes, sir.
Hey, how? For
Sir,
maximum angle
sir,
of incidence,
Yes, sir.
for
Sir, from
maximum angle of incidence, what should be the angle of the prism?
2C, sir.
Yeah, if I give C as 30 degree, what is 2C?
60, sir. Sir,
So
sir,
maximum
in that
is
case,
60.
it's not
It
possible, sir.
cannot be beyond 60,
Yes, sir.
right?
Yes, sir.
So angle of the prism is equal to 70 degree is not at all possible. Are you getting my point?
Yes, sir.
So please remember, for any particular prism, angle of the prism must always lies from critical angle to twice the critical angle.
Yes, sir.
Got it? Yeah. Now, deviation is given by the formula n minus 1 into a, right?
Yes, sir.
If I increase the refractive index, what happens to the deviation? If I increase the refractive index, what happens to the deviation?
So deviation also increases, sir.
Deviation also increases. Correct? No?
Yes, sir.
Yeah. For VIBGYR, for violet, refractive index will be more.
More, sir.
For red color, refractive index will be
Less, sir.
less. If refractive index is more for violet, deviation for violet should be more compared to the deviation of the red.
Yes, sir.
So which color is going to get deviate more?
So, violet, sir.
Violet. Andre, whenever I am going to incident the white light on the prism, which color will get deviated more?
Violet, sir.
Violet is get more deviated. Reason? Refractive index is more.
Yes,
For
sir.
red color,
So it is the least, sir, deviation.
yes, it is least deviated one, less deviation, because refractive index is less. Got it?
Yes, sir.
Any doubt in this today's session?
No, sir.
Okay. So in the next session, there is still two more concepts related to prism, that is angular dispersion and dispersive power. For 10 to 15 minutes, we'll discuss that concept. Then immediately we'll take up the MCQs, that is objective on these prisms. Okay.
Yes, sir.
Yeah. I will end up at this moment, Appa. We'll continue in the next session. Okay.
Yes, sir.
Yeah. Thank you. Bye-bye.
Thank you, sir.